Today's learning target is I can find the slope of a line and use the slope to describe a constant rate of change. Today we're going to be talking about slope. And slope it describes the steepness of a line. So if we take a look here, this line, the steepness of that line is the slope. Here's another example right here. Okay, the steepness of that line is the slope. When we find slope, we write it as a ratio. So here you can see I've written slope equals the rise over the run. Now the rise is the up and down change of a line. Or if we have that line on a graph like this, it's the change, the up and down change, which would be the change in the y-axis from one point to another point on the line. Sometimes you'll see that written this way. You'll see a triangle which stands for the change and then of y, so that would be the change in y. And the run is the vertical change. Okay, so on this triangle, this would be the run from here to here on any given point of this line. Okay, so it's the left to right, or the vertical change. On a graph, it would be the change in the x-axis, because that's what goes from left to right. And we can write the change in x this way. So that symbol is called delta x. It's the change in x. So to find the slope of a line, we can use the formula slope. And slope, whenever you see m, that stands for slope. And I looked up why that is, because I didn't know. And there's no definitive answer. There's some theories out there, but nobody knows for sure why m is used to find slope. But that's how we'll use it. So slope is equal to the change in y, remember the triangle means change, over the change in x. Now another way to write that would be this way right here. So we have slope is equal to, if you took the y-coordinate, subtracted one of the y-coordinates from the other y-coordinate, and then subtracted the x-coordinate from the other x-coordinate, that would give you the change in y over the change in x. So either of these is a fine way to find slope. Alright, let's take a look at how to find the slope of this line right here. Now the first thing you want to do, if the coordinates are not written down for you, like they are here, write those down, because we're going to see in a second that that's going to make it a lot easier. Okay, so we're going to take our formula and we want to find the change in y. And to do that, we're going to have to subtract the y coordinates from each other. Now we see y from one of the coordinates and we subtract it from y from the other coordinate. That's what this is showing. It doesn't matter which one you choose here, whether this is going to be your first set of coordinates or this is going to be your first set of coordinates. Okay, as long as if this is your first set of y coordinates, this also has to be your first set of x coordinates. Okay, so just decide. So for this one, I'm going to make this one my first set and this will be my second set. Alright, now as I look at my coordinates, I know the first coordinate is x and the second coordinate is y, so I make sure that I keep that in mind. And now I start by plugging in my numbers to my formula. So I'm going to go slope equals the second y, which I can see is 1 right here, so 1 minus the first y, okay, because that's the difference, the change, and there's my first y. So 1 minus 3, and that's going to be over the second x, which I can see is 3, minus the first x, which is negative 3. Okay. So m equals 1 minus 3 is negative 2. Okay. And 3 minus a negative 3. Remember, when I'm subtracting negatives, it's the same. I can change the sign to addition, and as long as I make the opposite of the negative, which is a positive, so that becomes 3 plus 3 is 6. And this is a ratio, so I simplify that down to negative 1 over 3. So the slope in this can be described as negative 1 over 3. Alright, let's look at one more example here. And in this one, I'm going to make this my first set of coordinates here, and this my second set of coordinates. So I've plugged those numbers. So here this 1 was the y in the second coordinate, and then 4 was the y in the first coordinate, and 0 was the x in the second coordinate, and 1 was the x in the first coordinate. So once I solve that out now, I get 1 minus 4 is negative 3, and 0 minus 1 is negative 1. So in this case, the slope is going to be the ratio negative 3 over negative 1, which, think about it as a division problem, would be negative 3 divided by negative 1. We know a negative divided by a negative is a positive, so this would be 3 over 1, or 3. So my slope in this is 3. Now you might be asking yourself, what is a slope of negative 3 over negative 1, or a slope of 3, or if I wanted to write it out, 3 over 1, what does that mean? So a slope of 3 over 1, okay, remember the top number in a slope means the change in y. So that would mean that for any point on this line here, so here's a point right here, okay, I can change the y positive 3. Okay, so I can go 3 up, 1, 2, 3, because a positive would be up. Now, the change in x is a positive 1. So I went up 3 for the y, and a positive 1 is right here, and it hits my next point. Now I could use the same, the down 3, or negative 3 and negative 1. I could start right here, and I could say down 3, so a change in the y is 1, 2, 3, because it's negative 3. And a negative 1, the change in x, would bring me 1 to the left, and that brings my point there. Now if I kept doing that, down 3 to 3 and over 1, you can see I keep hitting points in the line. 1, 2, 3 over 1. It would work the same way if I went 3 over 1. Okay, I would start at one point on the line, go up 3, 1, 2, 3 over 1, up 3 over 1, up 3 over 1. In today's assignment, you're going to be asked to find the slope of a line that passes through each pair of points. Okay, let me show you an example. This is pretty simple. It's what we just did here. First thing you're going to do is you're just going to figure out what's going to be your first set of points. So it makes sense. I'll just go that way, and this will be my second pair. Doesn't matter. You can flip-flop it. It won't make a difference. And now just use your formula. Okay, so the slope is equal to the change in y. So the second y minus the first y over the second x minus the first x. Now, once you plug in these numbers right here into these and then get your ratio, that's how you'd find your slope. So I plugged in my coordinates into my equation here. So the second y coordinate was 0, plug that in there. The first y coordinate was 2, I plug that in there and I subtract them. And my second x coordinate is 5, plug that in, and I subtract that from the first x coordinate, which was 1. So now I subtract that out, and when I do that, I get negative 2/4, which when I simplify gives me negative 1 over 2. So that would be my slope.